We are going to learn how to read scientific notation. The way we look at scientific notation is that to write something in a scientific notation or read it is the number to the left in here is a number that has to be between 1 and 10. Basically, I can write it as 1, I can write it as 1.1, I can write it as, I don't know, 2.345, right? I cannot have 11, I cannot have 0.9. It has to be a number that is between 1, the number 1 and 10, between, well, is equal to or less than. Is equal to or greater than 1, but less than 10. The second number that you will see, it's called a power of 10. And the power of 10 is gonna be always 10 raised to a certain power. That power in here is gonna tell me if I am talking about this number, if this number is actually smaller than 1 or if it's greater than 1. How is it telling me? The important thing in here is if the exponent is positive or negative. If the exponent in here is positive, when you think about positive numbers, right, we're moving to the right. So they're going to be numbers that are actually bigger, 1 or bigger than 1. And then if it's negative, I want you to remember we are going to be talking about decimals. And I will explain to you why. This in here, first I'm going to look at, and it says, tell me if the number is written in a scientific notation. Well, we said that scientific notation, the first number in here, right, that first number in there has to be 1 or greater than 1, however less than 10. Well, is 5.9 greater than 1? Yes, it is. Is it less than 10? Yes, it is. And here this is telling me, right, it's times 10 raised to a certain power, which is negative 6. However, this is written in a scientific notation, right? So this one, it checks. This one in here is 0.1 equal to or greater than 1. No, it's not, right? So this one is not written in a scientific notation. To write a scientific notation in a standard form. Standard form is, let's say, number 234, 0.825. All that is standard form. Now we're going to say, all right, well, 3.2, that is written in a scientific notation, right? Now this exponent is telling me, because it's negative, that this number in here is going to be smaller than 1 actually, right? In a standard world, in a regular world. So what do I have to do? Well, to make it smaller than 1, because that's the negative, right? That's what it's telling me. It's telling me I have to move the decimal point 4 places. To make it smaller than 1, I have to move it 4 places to the left. So I'm going to take the decimal point and I move it 4 places to the left. 1, 2, 3, 4. The decimal point now is over here. What do I do with the holes? There's nothing. And what is nothing? 0, right? So every hole in here will be filled in with 0. The answer to this is, don't forget your decimal point. And I have 3 zeros, 1, 2, and 3, and after them is 3, 2, 2. Please do not make the mistake of putting the decimal point over there again. The decimal point moved, right? The decimal point is no longer in there. So do not, please, do not write that decimal point any longer. In here we have 7.9, which we can see it is written in a scientific notation, times 10 to the 5th power. Where my exponent is positive, right? Well, if it's positive, I know this number is going to be bigger than 1 or greater. And here it was negative. I knew I want to have a decimal, right? I was going to the left. This exponent in here is positive. I am going to move my decimal point for that reason to the right. And how many times? 5 times. So I'm going to take this decimal point and I go 1, 2, 3, 4, 5. And every hole I see will get filled in with zeros. So my answer is 7, 9, and how many zeros? 1, 2, 3, 4. $790,000. $790,000. Sounds good?